Hello, my dear students. With you, Mr. Mahmoud Askar. At the first secondary school, our lesson today, Unit 2 in Algebra section. Lesson number 1 in Unit 2, Linear Inequalities. Linear Inequalities. We studied the inequality before, that it's as the equation 3x plus 10 more than 1. This is called inequality. This inequality may be in one variable or in two variables. Okay, this inequality in one variable because we have one unknown is x. Okay, and we want to show graphically the solution set of it. Okay, we want the solution set, then we will graph. Okay, maybe in R, maybe in R2. R2 means R cross R. Okay, let's start to solve this inequality. Okay, we will start to get x. Okay, how? The first step by subtracting, okay, 10 minus 10 minus 10 from both sides, then it will be 3x. Okay, more than 1 minus 10 negative 9 divided both sides divided by 3, it will be x more than negative 3. Okay, x more than negative 3. How can we graph this inequality? In R, we studied that before, that we will draw a number line. Okay, as you see, okay, and start with negative 3. Then I write 0 in the middle, 1, 2, 3, 4, and so on. Negative 1, negative 2, negative 3, negative 4, and so on. X more than negative 3, then I'll start from negative 3. Okay, and open the circle, okay, because x more than negative 3, not more than or equal, it's more than only. Okay, then I'll start after negative 3, that means negative 3 is open, as you see. Okay, more than negative 3, more than, then I'll go right. Okay, with an arrow, as you see. Okay, this is the solution set, or the solution in R. In R, this is the solution graphically. But in R2, then we should graph what? Yes, the plane. Okay, 0 in the middle, 1, 2, 3, 4, and so on. Negative 1, negative 2, negative 3, negative 4, and so on. 1, 2, 3, 4, and so on. Negative 1, negative 2, negative 3, negative 4, and so on. Okay, the inequality was x more than negative 3. Where is x? This is x. Axis. Okay, negative 3. Okay, from here I'll draw what? I'll draw a straight line, but it will be dashed. Okay, straight line represent x equal negative 3. This straight line, okay, its equation equal x equal negative 3. X equal negative 3. Okay, exactly, but I drew it dashed because x more than only, not equal. Okay, then I'll start after negative 3. Okay, where is the graph? Yes, all this area, okay, is the solution set of this inequality. Okay, This is the solution in R2 or in R cross R. Another one. Show graphically the solution set of the inequality x minus 1, okay, less than or equal for x plus 5, less than x plus 17. We can read it. For x plus 5 more than or equal x minus 1 and less than x plus 17, where x belong to R. X belong to R, then I'll write it graphically on the number line, not on lattice. Okay, let's solve the inequality first. How can you solve this inequality? In the terminals we have x, okay, x. How can we cancel this x? Yes, by subtracting it. Then from each side I'll subtract x minus x minus x minus x. Okay, hence x minus x is 0, it will be negative 1. For x minus x, 3x plus 5 less than x minus x 0, it will be 17, as if it's simplified. After that, I subtract 5 from each side. From minus 5, minus 5, minus 5. It's the opposite of 5, okay? It will be 3x in the middle. Negative 1 minus 5, negative 6. 17 minus 5, it will be 12. Divide each side, divide by what? Yes, divide by 3. Okay, it will be x less than 4, more than or equal negative 2. Hence, the solution set will be closed interval from negative 2, closed interval from negative 2 to 4. Okay, 4 is open. But here it was from negative 3 to infinity. From negative 3 open to infinity, it's always open. Okay, this is a solution set algebraically, but graphically we will draw it on the number line. As you see, I drew the number line, 0 in the middle, 1, 2, 3, 4, 5, and so on, negative 1, negative 2, negative 3, negative 4, negative 5, and so on. The interval from negative 2 and negative 2, guys, yes, equal and closed, negative 2. Okay, 4 not equal, 4 is open. Okay, and shaded this part. Okay, this is the solution graphically, as you see. Number 3, represent graphically the solution set of the inequality. Okay, x minus 3y less than or equal 3 in R cross R. R cross R means then we will draw it in the lattice after that. Okay, how can we graph this inequality? This inequality we will convert it into an equation. First step, convert it into an equation. X minus 3y equals 3. This is the equation. Okay, they are replaced less than. Okay, it will be equal only. Then I'll substitute about x and y in the table. Put x equals 0 and get y. Put y equals 0 and get x. Okay, put x equals 0. 0 minus 3y equals 3. Negative 3y equals 3. Divide negative 3, y equals negative 1. then y equal negative 1. Okay, if we put y equals 0, put y equals 0, x minus 0 equals 3, then x equals 3. X equals 3. And represent this table on the lattice. Let's see the lattice, please. 0 is the origin point, 1, 2, 3, 4, and so on in x. Negative 1, negative 2, negative 3, negative 4 in the opposite of x. 1, 2, 3, 4, y. Negative 1, negative 2, negative 3, negative 4 in the opposite of y. Where is the point 0, negative 1? 0, negative 1. 0, negative 1 here. Yes. The other point 3 and 0. 3 and 0. 3 lie on x-axis. Okay. Then I'll draw the straight line that passes through the 2 points negative 1 and 3. But note that the inequality was less than or equal. Yes, it contains equal. Then I write the straight line, okay, solid, as you see. Solid, not dashed, because we have equal. We have here equal, less than or equal. Okay, if it was less than only or more than only, then this straight line was dashed. Hence I drew the straight line, but the solution was inequality. Hence we will test what? Test the 0 and 0, the origin point. Okay, if it satisfies this inequality, it will be the area above the straight line. If it's not, it will be down off, because 0 and 0, the origin point, is above. Okay, let's test 0 and 0 in the inequality. Okay, 0 minus 3 times 0, 0. Then we can say that 0 less than 3. Yes, 0 less than or equal 3. 0 less than 3. That's right. Then the area, okay, it will be in the direction of 0. Where is the direction of 0? Up or down of this straight line? Yeah, it's up, okay, because 0 and 0 here. Then this area is the solution set, or the solution graphically, as you see. Example 4, represent graphically also the solution set of the inequality. We have here 4 inequalities. Okay, the first step, we should convert each inequality into an equation. X equals 0, y equals 0, y plus 3x equals 9, y minus x equals 1. Okay, this is the first step. The second step, we will draw each straight line that represents this equation. Let's start. How to draw x equals 0? X equals 0 is the equation of y-axis. The equation of y-axis. But note that x more than or equal 0. Then I'll start from 0 and go up. Okay. The second equation y equals 0. Y equals 0 is the equation of y-axis, but the inequality was more than or equal 0 also. That means we are in the first part of x-axis or the positive part of x-axis. As you see, this is the equation of what? This was x equals 0. This is y equals 0 from 0. Okay, that means our area will be at the first quadrant. Yes, it will be at the first quadrant. After that, y plus 3x equals 9. Let's draw the table. X and y. Put x equals 0 and get y. Put y equals 0 and get x. If we put x equals 0, then y plus 3 times 0, 0 equals 9. That means y equals 9. Yes, y equals 0, 9. If we put y equals 0, 0 plus 3x equals 9 divided by 3, x equals 9 divided by 3 equals 3, x equals 3. The second point, 3 and 0. Okay. Hence, note, we forget before that to put the numbers. Sorry guys. 0, okay. In the x-axis, we can put 1, 2, 3, 4 or the double of it, or the double. Okay. Why is the double? Because we have here 9. 9 is a big point. Okay. Then we will put 0, 2, 4, 6, 8, 10, negative 2, negative 4, negative 6, negative 8, negative 10. We can also use 1, 2, 3, 4, but here it will be negative 1, negative 2, negative 3, negative 4, and so on. Okay? By increasing 2, as you see. Here also 2, 4, 6, 8, 10, negative 2, negative 4, negative 6, negative 8, negative 10. The first point 0, 9, 0, 9, 9 lie in the mid point between 8 and 10. And the other point 3 and 0, 3 in the midpoint between 2 and 4. The points here. Okay. The inequality was less than or equal. Then I'll draw the straight line. Okay. I'll draw the straight line. Solid. This is the equation of the straight line of the equation y plus 3x equals 9. Okay, the last inequality, I represent the equation in a straight line. Put x equals 0, get y. Put y equals 0 and get x. Put x equals 0, y minus 0 equal 1, y equals 1. 0 and 1. If we put y equals 0, y equals 0, 0 minus x equals 1, negative x equal 1, then x equal divided by negative 1, x equal negative 1. Then the point, the first point 0, 1, 0, 1. Here we can draw with another pen, 0, 1, and the other point negative 1 and 0. Negative 1 and 0 here. But note that the inequality here of this equation, the original inequality, okay, less than only, without equal, then I'll draw the straight line, but it will be dashed. It will be dashed, as you see. This is a straight line of the equation y minus x equals 1. Okay, the area between the four straight lines, okay, is this quadrilateral O, A, B, C. This quadrilateral is the area between the four straight lines. Okay, the first one was x equals 0. The second, y equals 0. The third, y minus 3, y plus 3x equals 9. And the fourth was y minus x equals 1. The area, this area, and the shaded part is the solution of our system of linear inequalities. Thank you for listening today, and wish you a good day.